Hi everyone, my name is Karina and I would like to talk about Chapter 6 of Managerial Economics in a Global Economy by Dominick Salvatore about production theory and estimation. Production is the transformation of inputs or resources into output of goods and services. Inputs are the resources used in the production of goods and services. Inputs are classified into labor, capital, and land or natural resources. Fixed inputs are those that cannot be readily changed during the time period under consideration, while variable inputs are those that can be varied easily and on very short notice. The time period during which at least one input is fixed is called the short run, while the time period when all inputs are variable is called the long run. Production function is an equation, table, or graph showing the maximum output of a commodity that a firm can produce per period of time with each set of inputs. This equation reads, the quantity of output is a function of or depends on the quantity of labor and capital used in production. The table gives a hypothetical production function, which shows the outputs that the firm can produce with various combinations of labor and capital. This three-dimensional figure shows the production relationships from the table before. The height of the bar refers to the maximum output that can be produced with each combination of labor and capital shown on the axis. In this figure, the horizontal and inclined axis measure the labor and capital inputs, while the height of the surface gives the maximum level of output resulting from each input combination, all assumed to be continuously divisible. Here, by holding capital constant at 1 unit and using labor as a variable input, we can derive the total product of the variable input. The marginal product of labor is the change in total product per unit change in labor used, while the average product of labor equals total product divided by the quantity of labor used. The output elasticity of labor is equal to the ratio of marginal product of labor to average product of labor. The total marginal average product of labor and output elasticity from the table earlier is calculated in this table. The top panel shows the total product of labor curve, and the bottom panel shows the marginal and average product of labor curves. The stage 1 of production for labor corresponds to the rising portion of the APL. Stage 2 covers the range from maximum APL to where the MPL is 0. Stage 3 occurs when MPL is negative. The marginal revenue product of labor equals the marginal product of labor times the marginal revenue from the sale of the extra output produced. The marginal resource cost of labor is equal to the increase in the total cost resulting from hiring the additional unit of labor. The optimal use of labor is reached when the MRPL equals MRCL. The firm's profits are maximized when the MRPL equals MRCL, which is when the labor is 3.5 units. The intersection point between MRPL and MRCL describes the optimal use of labor. To examine the production function when there are two variable inputs, we can use isoquants. Isoquants show combinations of two inputs that can produce the same level of output. Firms will only use combinations of two inputs that are in the economic region of production, which is defined by the portion of each isoquant that is negatively sloped. This is an example of isoquants. Higher isoquants refer to higher levels of output. The economic region of production is given by the negatively sloped segments of isoquants between line 0VI and 0ZI. The marginal rate of technical substitution equals marginal product of labor divided by marginal product of capital and equals the reduction in the amount of capital used divided by the increase in the quantity of labor used. MRTS is equal to the absolute value of the slope of the isoquant. When an isoquant is a straight line, the inputs are perfect substitutes, while for the right-angled isoquants in the right panel, the labor and capital are perfect complements. To determine the optimal input combination, we can use isoquant and isocost. Isocost line represents various combinations of two inputs that a firm can purchase with the same total cost. Total cost equals wage rate of labor multiplied with the quantity of labor used, plus the rental price of capital multiplied by the quantity of capital used. C per R is the vertical intercept of the isocost line, and minus W per R is its slope. This is the example of isocost lines from different combination of C, W, and R. The optimal input combination is given by points D, E, and F, where each isocont are tangent to each isocost. The slope of the isocont or marginal rate of technical substitution of labor for capital is equal to the slope of the isocost line or ratio of input prices. This figure describes the optimal input combination for input substitution in production. Returns to scale refers to the degree by which output changes as a result of a given change in the quantity of all inputs used in production. For a given proportion increase in quantity of all inputs used in production, it is a constant returns to scale if output increases in the same proportion, increasing returns to scale if output increases by a greater proportion, and decreasing returns to scale if output increases by a smaller proportion. In this example, when all inputs are increased by 100%, the output in the left panel increases by 100%, showing a constant returns to scale. The output in the center panel shows an increase of 200%, which means it has an increasing returns of scale, while the increase in the right panel is 50%, showing a decreasing returns of scale. This is the production function, which is most commonly used in empirical estimation, called the Cobb-Douglas production function. There are two types of innovations: product innovation and process innovation. Product cycle model stated that the firms that introduce an innovation eventually lose their export market and even their domestic market to foreign imitators facing lower production costs. In just-in-time production system, every component of a product becomes available just when needed. Competitive benchmarking is the comparison of the efficiency of a firm's production methods relative to its competitors. Computer-aided design is a technique that allows R&D engineers to design a new or changed product or a component on a computer screen, while computer-aided manufacturing is a technique that allows R&D engineers to issue instructions to a network of integrated machine tools to produce prototype of the new or changed product. Okay everyone, I hope this video can help you to understand more about this subject. Thank you very much.